quiz, like 0 out of 5 on your 2 chances, completely fail, you can still redo the quiz. Like after we cover the material and after you guys think that you understand what we're talking about, if you feel that you need those 5 extra points, well, those 5 points, I can open the quiz again. I can let you do it when you feel more comfortable. Okay, so this is not a quiz to prove what you know because it's a new topic. This is a quiz to make sure that you read before class. That's it. Something that I didn't mention on Monday, a couple of things that there's no lab this week. The lab is going to start next week. The person that's in charge of the lab is Amy Beatty. Her office is right behind here, at the next office. And she's in charge of the labs. I'm a little bit afraid of her, so I let her do her own things. And she just sent me, whenever she's ready, she sent me the grades, and I say thank you, and that's as far as our relationship goes. That's it. She gave me a little bit of candy in Christmas, and I say thank you, and we don't talk each other until the next question. It works, so I'm not gonna mess it up with that. So anything that you have to do with labs is gonna be with her. Labs are gonna be every other week. So just because we try to limit the number of people in the classroom, so every other week you're gonna have a lab. So during the whole semester, it's only gonna be 6 labs. Okay, so it's a little bit less than usual, half of what we usually do. Okay, now the other thing is regarding grading. I don't know if you saw that on the syllabus, but the lowest grade that you can get in any exam, any assignment, any exam, any homework, any assignment is 50 over 100. You cannot get below that. Even if you do an exam and you just write your name and you just say like, I'm done, I have no idea, that exam is 50 over 100. Okay. The reason that I'm doing that is that if in the first exam, in the first midterm, you get 0, then you drop the class, because there's no way you can, even if you get 10%, if you get 100% in the second midterm and you get 100% in the final, you're not gonna get over 60. So most people is like, screw it, where I'm wasting my time, I'm gonna drop it. So I think that's a little bit unfair because it doesn't show your progress as a student. So if you do a really, really bad exam, but you get a 50, and then your next 2 exams are really good, then you can get a B, you can get a B+. So I think that's a little bit more fair. Okay, makes sense? People in the online, does that make sense? It's kind of weird. They don't have the cameras on, so I don't know if they're awake. Maybe they just have me as a noise. Anyway, so the first kind of topic that we're going to be covering is called vectors. And vectors, many of the quantities that we talk about in physics, we treat them as vectors. Is one of those fundamental mathematical tools that we need to describe some physical quantities, some physical phenomena. So we need to describe vectors, and we need to find a mathematical way to work with these kind of numbers. You are probably more used to work with scalars, which is kind of like the regular numbers that we use to describe things. So the difference between a scalar and a vector is that we use scalars to describe things that only need a magnitude to be described, to be described. So for example, weight. If I ask what is the weight of a book, well, you only need to tell me it's 3 pounds or 4 pounds. Or the weight of a dog, you can say like, well, that's 40 pounds. You only need that magnitude, 40, and a unit, 40 pounds. Time, I can tell you, well, what time is it? Well, it's 12:15. So it's only one number. How long it takes you to take a shower? Well, 15 minutes. Okay, you will only need that number to describe the quantity of time. Temperature, well, is inside here is 80 degrees, and outside is 65 degrees. Okay, we only need that number. But there are quantities that is not enough to just know the magnitude. For example, force, and I'm gonna do this here. Force is a quantity that is not only important to know how much of a force I'm applying, but you need to know in which direction it's being applied. So if I pushing the book down, well, it's not gonna move at all. And I can push really, really hard, and the book is gonna deform. Well, I'm not that strong, but you get the idea. I'm pushing down, it's not gonna move. But if I push up, well, I'm gonna lift it. So the way it behaves is gonna be different. Of even if it's the same amount of force, it's gonna be a little bit different of the direction of the force. I can apply a force with my hands on both sides of the book, and I can squeeze, and the book is not gonna move. Again, it can deform, but it's not gonna move. But I can apply it on the top, you guys can see, but I can apply on the top and in the bottom. And if I apply the same force, the book is gonna rotate. So how I apply the force, where I apply the force, and the magnitude of the forces matter. And they describe complete different behaviors. So in order to describe that, in order to quantize that and to be able to describe the motion, we need to work with vectors. So a vector is a quantity, or a vector needs to have a magnitude and a direction in order to describe a thing. Okay. Forces are vectors. Accelerations, velocity are vectors. What else? Momentum is a vector. There's a lot of vectors. We use them a lot. One particular vector that's kind of weird. Oh, and by the way, I'm recording this, so you can have access to it later. Okay, so a particular. Whoa, there's a little delay. That's kind of weird. A particular vector that is important and is one of the basic vectors is called displacement. Okay, and displacement is different than distance. It's kind of weird seeing me right. So let's say, for example, that you want to go from point A to point B. Okay, this is your initial and final points. Now, there are different trajectories, there are different paths that you can follow. The fastest one, or the shortest one, will be to just go in a straight line from point A to point B. But that's not the only one. You can follow something like this, or you can follow something like that. Okay, and I'm gonna call the one on top 1, the one on the top in the middle path number 2, and the one on the bottom path number 3. Okay, in terms of displacement is a vector, and for displacement and for vectors, so displacement is a vector. And when we work with vectors, the only thing that we care is what is the final condition or the final state, in this case, the position, and what is the initial position. Okay? Those are the only things that we care. We only care about the initial position and where's the final position. So for these three paths, for path number 1, 2, and 3, because all of them have the same final position and they all have the same initial position, they all have the same displacement. Okay, exactly the same. The distance is different. The distance is scalar, and distance is the length of the path, how far or how big is one with respect of the other. So you can say, well, the distance of path number 3 is the longest, and the path of and the distance of path number 2 is the shortest. Okay, so in this case, distance will be a scalar. And this will be a vector. Okay, one of the consequences of having displacement as a vector is that every single unit or every single calculation that we that it implies displacement is also going to be a vector. So, for example, the way we define velocity is the change of displacement in respect of time. So velocity is also going to be a vector. Acceleration is a change in velocity with respect of time. So acceleration is also going to be a vector. And anything that's kind of derived from displacement is also going to be a vector. So it's kind of important. Okay? Make sense so far? Way in the back. What's your name? Keely. Keely. Oh, okay. Yeah, perfect. You are the ones that were missing. Okay. So far, so good? Okay. Okay. Now, the way we represent change, that's a quantity is changing, is by using a mathematical symbol. And that mathematical symbol is the Greek letter delta. So if I say delta x, basically I'm saying the change in position in the x direction. If I say delta t, is the change in time. And the way we calculate this delta, this is an equation. And it basically means x final minus x initial. And this will be t final minus t initial. So for point A and point B, if I say that point A is at a mark of 1 meter and point B is at a mark of 10 meters, then delta x will be 10 minus 1, it will be 9 meters. Okay, so that's the displacement. Okay. So this delta, we're gonna be using it a lot, and it just means that it's just a change. It's a change from an initial state to a final state, and the way you calculate is by final state minus initial state, and whatever you get, that's gonna be your delta t, delta x, whatever. Okay. Now, when we work with vectors, one thing that we need to establish is a frame of reference. So the most traditional frame of reference is what's okay, and a Cartesian plane is nothing but two straight lines perpendicular to each other. The intersection of the two lines is what we call the origin. So this will be my origin. And traditionally, we call the horizontal line the x-axis, and the vertical, we call it the y-axis. But it can have different labels. It can have different names. We're going to be using this one for time. It can represent many things. It can be a plane that represents velocities or positions. It can represent accelerations. It can represent whatever you want. Okay. Is divided in quadrants. So this will be the first quadrant, second, third, and fourth quadrant. Okay. So the way vectors are represented is just basically with arrows. The length of the arrow is proportional to the magnitude of the vector. And the direction is usually represented as an angle. And it's an angle with respect of an horizontal axis, usually the x-axis. Okay. A property of vectors is that we can change the position of the vector. We can move this vector in this Cartesian plane, and we can move it everywhere we want. The only thing that you cannot, so as long as you keep the same magnitude and you keep the same direction, that vector can be displaced anywhere you want. So you can have this vector and I can displace it here. And it's perfectly valid. Or I can move it somewhere else. And as long as I keep the same direction and I keep the same magnitude, that's the same vector. If anyone has a question, just raise your hand. And if you guys online, if you have any question, just type it on the chat, and I'll just don't let me keep going if you get stuck. So you can move it, that vectors, you can move them and you can place them anywhere you want. We move them to add them and subtract them. Something that is very common is to move the vector and put it at the origin. So the initial state of the vector, we put it at the origin, and then we draw the vector. Okay, we do that to calculate the components and calculate the components of the vector and to calculate their magnitude and direction. So we're going to do a quick example. So let's say that I have a vector A, and I'm going to say that this vector A, this point over here, that vector, that point over there is point 6,3. The first number, that's the x coordinate, and the second number is the y coordinate. And this is a very common way to represent points in a Cartesian plane. So what I'm saying is, okay, that this point at the end of this vector is 0.6 in the x coordinates and 0.3 in the y coordinate. So this will be 6. And this will be 3. I'm assuming that none of you have seen this before, or if you have seen it, you have seen it long time ago. So those of you that have seen physics before, just stay with me. Just bear with me. I know that this sounds very repetitive. For those of you that have not seen it before, if you feel like I'm going too fast, just let me know, and I can try to explain it differently. Okay. Okay. So this 6,3 represents this point at the end. So this is my final state of the vector. The initial state of the vector, because I move the vector to the origin, then the initial state is 0,0. Okay, so this vector, the vector A, has an x coordinate of 6 and a y coordinate of 3. Okay, so one of the advantages of being able to move the vectors and to place the origin of the vector at the origin of the Cartesian plane is that then the vector is defined just by the final state. Okay. Your name? Erin. Erin, makes sense? Are you sure? Okay. It's hard to read facial expression. I can only see the eyes, so I don't know if you guys are concentrating while joining, or that's one advantage. You can join and I don't know it. Yes.
Is there any reason that you wouldn't want to put a vector at the origin point, or is it just a preference thing?
Oh, no. That's we're gonna be using a lot. So one thing that happen is that at the beginning, what we're gonna see is that we're gonna ignore the physical dimensions of the objects. And we're gonna assume that all the mass of the object is concentrated in one single point. And then to try to figure out what forces apply to that point, we're gonna put the point in the origin, and then from there we put the forces. So it's very common to put the vectors at the origin. Okay. Okay. So from here, I have this vector A, with components 6 and 3. So this is the x component of A. And a sub y, this is the y component of vector A. Okay, so remember, to define a vector, we need magnitude and we need direction. So that's what we're gonna do. We have the components of the vector. I know that the components of this vector is 6, 3. Now what I want to do is to calculate the magnitude, and I want to calculate the direction. So for that, notice that here I have a triangle rectangle. It's a triangle rectangle. The angle that I want is this lower left angle. Adjacent side is going to be 6, and the opposite side is going to be 3. So the hypotenuse of this triangle, that's the magnitude of the vector. So the magnitude of the vector, which is usually represented with the name of the vector between two vertical lines, this is going to be, it's just the Pythagoras theorem. So the square of the components, and then the quantity, it gets all square rooted. Okay, so this will be 6 square plus 9 square. This is what? 36 plus 81? No. Sorry. This will be 6 square plus 3 square. So this is 36 plus 9. This is 45. So this is 6.7. So 6.7, that's the magnitude of this vector. Okay? Makes sense? Now, to calculate the angle is by using the trigonometric functions that you hopefully learned sometimes in high school or some pre-calc classes. How many of you have taken calculus? How many of you have taken pre-calc? Okay. So if you remember your trigonometric functions, the SOHCAHTOA kind of thing, your sine, cosine, tangent, that's all the math that you need. Pythagoras theorem and the SOHCAHTOA, and that's all the math. Like, I swear, like 80% of the math that we're doing is just those two things. So if I want to calculate theta, well, you have different options. You already have the hypotenuse. So you can use sine or cosine, or you can use tangent. So because the magnitude is 6.7082, blah, 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 I'm not going to use the hypotenuse. I'm just going to use the tangent. So I know that tangent of theta is opposite over adjacent. So in this case will be the y component over the x component. So theta will be the arctangent of 3/2. Oh, sorry, of 3/6. And this will be 26.5 degrees. Yeah? Make sense? Everybody? Yeah? Okay. Yes, Grace, that's the direction. So that would be the direction. So it will be that theta is 25 degrees, 26 degrees from the x-axis to that vector. Okay? Okay, so now what we're going to try to do, you're going to try to do a couple of problems on your own, and then we'll do it together. Then I'll show you the results, okay? Now, in this case, try to, everybody, also the people that are at home, try to do it. Make sure that you have your calculator in degrees and not in radians. Otherwise, it's going to give you a complete different answer. Try to do it in degrees. If you don't have a calculator, you can use your phone. The only thing that you need to have is the trigonometric functions, which I think all of the calculators have it. So, no excuses. So we're going to do we're going to do 3 problems right now. So the first one is pretty much the one that we did right now, or something very similar. Okay. Bless you. Okay, so those are the 3 problems that we're going to try to solve right now. The first one is very similar to the one that we just did. Okay. And for each one problems, I want to know the components of the vector. So this is going to be vector A, vector B, and vector C. So the components of the vector. So basically, what is the values of the AX and the AYs? Magnitude, and direction. Okay, and again, for the people that are at home, try to do this also on your own. Unfortunately, I don't think I can see your work, but if you have an answer, you can just put it in the chat, and then I'll hopefully when I solve it in front of you, then you can see if you made a mistake, you can see where you made the mistake. Yeah, go ahead.
I can figure out how to do it. I have it, I just can't like get the finance. Because I've heard that thing and it's not working. I haven't done that in
Isn't that the one?
I tried it, but it just said 0. And that's it. Okay.
So you will be ready? Okay. Okay, so I'm gonna solve problem A really quick. So components, so the x component of A is gonna be 3. The y component of A is gonna be 10. Pretty straightforward. The magnitude is just gonna be the Pythagoras theorem. So it's gonna be 3 squared plus 10 squared, square root of that. That's gonna give you square root of 109, which is what? Tell me again your name, sorry?
Kennedy,
Kennedy, what you got? 10.3?
10.4.
10.4. 10.4. And then for the magnitude, you can do any of the Pythagoras trigonometric functions because I know the values of AX and AY. I prefer to use that just in case I did any mistake in the calculation of the hypotenuse. So theta will be the arctangent of 10 over 3. And that gives me 73.3 or something like that, something close to that. I write arctangent. Some places you're going to see like tangent inverse. I don't like this thing just because I'm annoying. But if you like that, that's fine. It makes sense to you. That's fine. I just make sure that when I write this, it's the same thing like that. Okay. Now for part B, anyone is done with part B? And your name?
Hallie.
Hallie. Hallie, can you tell me what is your x components?
The x component is -6.
The x?
Oh, sorry, -5.
5.
Sorry, I missed one.
No problem.
And y is -6.
And the magnitude?
7.8.
7.8. And the angle?
-50.2 degrees.
15?
50.
50. 50.2. Okay. And your name?
Eleanor,
Eleanor. Okay. X component of C.
-5.
-5. Y component? 6. Magnitude? 7.8. Angle? Negative? -50.2. Okay. Now remember, the only thing that we need to describe a vector is the magnitude and direction. It's the only things that we need, nothing else. Vectors B and C, they are different vectors. They are mirror image one of the other. They are not the same vector. It's not that B is displaced somehow and you ended with C. You need to rotate it to have it. So they're not the same vector, but because they have very similar components, your calculator doesn't know where the vector is, doesn't know where, if it's in the first quadrant, second quadrant, third, or fourth quadrant. So your calculator is going to give you the same values just because of the components that you have. So one of the things that you need to be careful with working with vectors and we're trying to find the components and direction is what is the calculator telling you? Like, don't follow the math blindly. Try to make sense of those numbers. So in the case of B, you have 50 degrees, negative 50.2 degrees. So that 50.2 degrees, that's going to be this angle over here. And the negative sign just going to mean that it's is below the x-axis. Okay? The 50 on C, if I use tangent, I know that tangent of C is opposite over adjacent. And my opposite is going to be 6. And the adjacent is going to be -5. then that means that the angle that I'm calculating, even though it's negative, the angle that I'm calculating is this one. And the negative sign here basically means that it's from the negative x-axis and I'm rotating clockwise, which is very weird. In case number A, the 73.3, I'm calculating this angle and it's from the x-axis and I'm rotating counterclockwise. Okay, makes sense? So, no, it doesn't make any sense. It's like you just put signs and move the counterclockwise. When do I do counterclockwise? When do I do clockwise? When it's under the axis and when it's above the axis. When you work with vectors, and in general, when you work with physics problems, one of the best advices that I can give you is to do the diagram. Do the drawing. You do the axis and you draw where the vector is, and then you use that drawing to figure out what the math and what the numbers represent. The math itself is not going to be enough. The calculator doesn't know if you are in what quadrant, doesn't know where your initial and final states. If you just follow the math, you probably are not going to misunderstand what the problem means. Okay? Questions so far? No? Okay. So now we're going to do something different. Last problem for today. Okay, so what we did was basically giving you the components of a vector, how to calculate the magnitude and direction. That's what we just did. Now we're going to do the opposite. I'm going to give you the magnitude and direction of a vector, and what I want you to do is to calculate the components. So I'm going to have a vector, and the magnitude of the vector is 10, and this angle is 30 degrees. Okay? So the way you do this is, again, you imagine that you have a triangle rectangle with an hypotenuse of 10 and an angle of 30. So you need to go through your trigonometric functions. So I know that sine of theta is going to be opposite over hypotenuse, and cosine of theta is going to be adjacent over hypotenuse. So in this case, the opposite is going to be my y component, and the hypotenuse is the magnitude of the vector. The adjacent is going to be the x component, and the hypotenuse is the magnitude. Okay, so to calculate the y component is going to be the magnitude of the vector sine of theta. So in this case, will be 10 sine of 30 degrees. And for the y component, for b, sorry, and for x, I'm going to be using cosine. Sorry, this is 5, and this is 8.66. Make sense? What's your name? Alexis? Alexis, make sense? Okay. Does it make, yes?
When it comes to sig figs, how many do you want?
2 is will be more than enough. So, so try to find out what are the components of this vector. So it's vector B has a magnitude of 12. And this angle over here, I'm going to say that is 20 degrees. Now, this is one of those problems that if you do the math, you're going to get a result, but try to match those results to the drawing and be careful with the signs. Are you good at it? You go to 7. Try to do the other colors, see if you get some result. I mean, you just need to do one of them. Okay, so if I draw a triangle rectangle, this is my 20-degree angle, this is my 12 units hypotenuse, and then I want to calculate what is the y component. So this is going to be my y component, and this is going to be my x component. So this is the opposite side, so I'm going to use sine of 20 degrees is going to be opposite over hypotenuse. So from here, the y component is going to be 12 sine of 20. No. Yeah? Yeah. And I'm going to get 4.1. 4.1 units. Okay. And then to calculate the x component, well, I would use cosine. Cosine of 20 will be the x component over 12. And from here, the x component is going to be 12 cosine of 20, and that's going to be 11.3. I'm just going to round it up a little bit. That's the math. That's the result that you got from your calculator. There's nothing wrong. This is the solution that it gives you from your calculator. But when you try to match these results to your diagram, they don't match because the x component of this guy has to be negative. It's pointing to the left. So even though the calculator tells you that it's positive, like, nope, the the y component, yeah, the y component is pointing up. That's going to be positive. That's fine. But the x component has to be negative. Okay? So you have to be a little bit careful. Like, don't follow the math, don't follow the calculator blindly. You need to match it with your drawings. Okay? Make sense? Any questions? Any questions back there? Online? Nope. Okay, so I'm gonna let you guys go a little bit early so that you avoid the crowds on the hallways. Although nobody's taking classes on the classrooms. Okay. Okay. See you guys on Friday. And have a good day.
Okay, so I have a question about the lab. So with the fact that we get paired up with someone, right, and then we do it every other week, do we have to like sign up for a week that we're doing it, or do we just email you when we're gonna show up, and then when our partner's gonna show up, or how does that work?
So Amy's gonna be coordinating all the labs.
Okay.
And I think what she's gonna do is she's gonna send emails and she's gonna give you a choice of when you want to be.
Okay.
I think even though you are paired with someone, most people are gonna be working individually. So
Okay.
you're gonna be assigned one day and then your partner is gonna be assigned another day.
Right, I just didn't know specifically because there's some other classes that are like, all the labs are kind of doing that same thing where you're doing it one week and then your partner's doing it the other week. But other classes have had like a sign up thing kind of with it, so I didn't know specifically how.
No, we don't have a sign up.
Okay.
Probably that she's gonna send an email and then you're gonna.
Probably before next week.
Yeah, definitely.
Sounds good.
Okay, no problem.